Welcome, guys. So this problem, let me solve Leetcode section 1025. Before I start, please be sure to subscribe to my channel. Okay, so Alice and Bob turn play again, and initially choose x, right? X is less than from 0 to n, and if n must be n is divisible by x, and replacing the number n on the checkboard with n minus x. Also, if the player cannot make move, then they lose the game. Okay, so the first fact is that the player always can make a move, right? Because n is always divisible by 1. So actually, we don't have this condition. Okay, so the only remaining condition is that if you get 1, then you lose. Okay, so let me just write down a fact. Okay, so the fact is that if n is 1, then that person lose, right? Because there's no move they can do. Okay, and other than if n is larger than 1, then that person do not lose, right? So lose is only visible. Is only if n equals 1. Okay, so for this kind of problem, I guess usually we use the mathematical induction, and then we guess the answer, and then we prove it. Okay, so if input is 2, then the true, right? Because Alice is first one, so Alice can choose 1. Okay, so let me just write it. Okay, so if Alice at 1, right? Alice, the answer is false, because Alice will lose. But 2, Alice can win, because Alice can take 1. Then the Bob will need to take 1, so Bob will lose. Okay, so 3, right? 3, right? So the problem is that 3 is false, right? So the key is that so now the key is that if at 3, right? If at 3, then Bob can choose 1, right? So Bob. So that means everything is false. Bob can choose 1 to make 2. Then right? Sorry. So at 3, right? Alice can only choose 1, right? Because 3 is a prime number. So Alice can choose 1, and choose 1 become Bob, right? So Bob can win. So Alice will definitely lose. Okay. So at 4, right? You can change. So 4, the answer is the same, right? 4. If I was Alice, then I can just choose 4 to 2, right? So Alice. How about 5? So 5 is a prime number, right? So if Alice at 5, the only way you can get is 4, right? But if you go to 4, 4 is a winning position for anyone. So 4 is a winning position, 2 is a winning position. So this is false, right? And then if 6, right? 6, the Bob can that Alice can just directly go to 2, right? So 2 is a winning position because 2 is divisible by 6. Okay. So from this theorem, from this observation, we have a theorem. So theorem, if n is odd, is even, then Alice win. Because Alice is the starting person. So an even number is a winning point. Otherwise, Alice lose. So that means answer is true. This is false. Okay. So how about we just start? Okay. So you can try the n equals to whether it's 0, right? If n is even, then Alice win. If n is odd, then Alice lose. Okay. So yeah, this is the answer. Okay. So I guess this is the answer, but yeah. So we are doing math, right? So we should prove it. Okay. So if n to 2, right? So that means n is odd. N is even. Sorry, n is even. So Alice can choose 2, right? Because n is divisible by 2, right? So that means it becomes n minus 1, right? So the problem becomes the problem becomes also let me see. Okay, yeah. Sorry about that. I think you should. Let me just write it. Okay, so I claim this is the answer. Okay, so that means n is winning point, right? N minus if n is even, so even number is a winning point, and odd number is a losing point. Okay, so the proof can be done by mathematical induction, right? So mathematical induction. So I suppose this rule works. So it is works for k, right? Sorry, for n less than k. So the ground truth is for k equals to 2, or maybe 3. Okay, so 3, 2, right, 1. So this is the losing point. This is losing point, and this is the winning point. Okay. So I use mathematical induction. Okay. So now suppose I was in k plus 1. So in k plus 1. Okay. So there are a few kinds of condition. Okay. So suppose k plus 1 is odd, right? So if k plus 1 is odd, right, then I take any number, right? So the only number I can take is if k plus 1 is odd, then the only factor for k plus 1 is odd, right? So then I will take some odd number. So k plus 1 will lead to another odd number, right? But from mathematical induction, this number is losing points. Right? So induction works, right? We start from odd, then we always lead to odd, right? So losing points go to losing point. I start from losing points, and I take odd number, right? Then it become other persons. So suppose sorry, what I'm writing about. So I start from odd, right? So odd minus odd is even, right? So I lead to an even number. So this even number is winning points. And then so this is losing point. Okay, so I start from odd, right? And I give somebody, then somebody is a winning point. That means I go from losing point to losing point. Okay. And the same reason, if k plus 1 is even, right? Then I can take 2, right? I can take 2. If I take 2, I become k minus 1. Then this is still the, then it is sorry. I mean I can take even, right? So I can take minus 1. I can take 1, right? It become k. So what is k, right? K is this k, right? So suppose k plus 1 is even, then k is odd, right? So this is the losing point, right? So Bob will lose, but Alice will win. So this is a winning point. So from the mathematical induction, we know that if k plus 1 is odd, then losing. If k plus 1 is even, then win, right? So from these induction steps, then we can say that these rules, right? These rules works for k to k plus 1, then works for all integer. Okay, for all positive integer. Okay, that's the proof. So I apologize for my bad writing, but I guess you guys know. I will see you guys in other videos. Thanks. Be sure to subscribe to my channel.